Hi everybody. So I'm going to hook up the second and last circuit of Lab 11. And this circuit is a ripple counter IC, the 74LS93. So that's one that we looked at in our class notes, and it has 2 clock inputs, but if I tie the output of Q0 to the CP1 clock, I can have a 4-bit counter. Okay, so that's what I'm going to do. I'm going to let you look up the pin number and put the pin numbers in your lab, but I'm going to connect the circuit. So I have VCC on pin 5. There's not too many connections, so I'm going to see if I can keep my wires a bit short so that you can see everything clearly. So pin 5 going to VCC. Okay, there's pin 5 to VCC. Pin 10 is ground. And this is a 14-pin chip. 10. Okay, pin 10 to ground in the blue rail. Then I am going to connect pin 12 to pin 14 because that is the connection, pin 14 being the CP1 clock and pin 12 being Q0. So let's see. I'm looking for a tiny jumper. I'll just use this. So I'm going to go 12 to 14. Now I do have 2 reset lines, and these 2 reset lines are on pins 2 and 3, and both of those we should tie together so that actually I'm going to leave them separate. So these input lines 2 and 3, a high will actually clear them. So I need to set them low. And so these are our active high inputs. So I'm going to set 2 and 3 to ground to get them out of the way. So that's opposite of the other resets that we've been dealing with so far. And my wire color really doesn't mean anything here. I'm setting them both to ground. And I'm keeping them separate right now because I'm going to connect them to different places in the future. And so the only thing I have to do, the only other thing I have to do is to set my clock, my main clock, to a button. So that is coming in on pin 1. And that can go to my button. And then I am going to send my outputs to the LEDs. So I have pins 12, 9, 8, and 11 going from least to most significant. So let me take my LED wires. Most significant bit is on pin 11. Next most significant is on pin 8. The next one is on pin 9. And the last one is on pin 12, which is also tied to pin 14. So I'll connect to 14 just because it's easier, but it is tied to 12. Okay, and that's actually all the connections that we have for this first part. So I'm going to turn power on. I've got a fixed 5-volt supply, And I'm going to momentarily set the two reset lines high. So I'm going to momentarily set them high and then set them back to 0. I popped this pin out, so momentarily set it high and back to 0, and high and back to 0. Now when I push a button, I get 1, 2, 3, 4. 1, 2, 3, 4. Something tells me that I have connected these outputs not in the right order. So I am going to double check that. I have one light that is not even coming on. Now that could be a wire issue, so right away I'm going to check the connection between pin 12 and 14. And I'm going to grab a different wire. Okay, I'm going to reset these guys again. I'm going to use a different wire for pin 3 because that one keeps falling out and I'm not enjoying that. I'm just pushing the button to test my outputs. And I'm still not seeing what I should. So the first thing I'm going to do is double check my pinout diagram to see if I actually have the outputs in the right order. And I didn't do a little tiny cutout of my pinout diagram this time, so I have to look up the picture again. Pins 12, 9, 8, and 11. 12, 9, 8, and 11. That is what I have. And then CP1, oh, it's on pin 1. So there's the mistake that I made. My CP1 is actually pin 1 and my CP0 is actually pin 14. So I got my clocks backwards. And that explains why things looked all mixed up. So I actually have to connect pin 12 to pin 1, and then it's pin 14 that is my main clock. And I guess I should have turned power off before making those connections there. So I'm going to reset all my inputs, set my reset lines back low because they're active high. So I don't want them to be active. I want my counting to be controlled for my button pushes. And here I go. 1, oh, I think that was a double push. 3, 4, 5, 6, 7, 8. Ooh, I went straight to 9, 10, 11, 12, 13, 14. And I went straight to 1. I think I'm getting some multiple button pushes going on here. Some glitches, which are making it seem like I have extra counts. Okay, so 15. One, two, three. Whoa. I'm going to try a different button just out of curiosity. And let me do a reset. One, 2, 3, 4, 5, 6, 7, 8. Oh, it went straight to 9. 10. I think what I'll do is I'll set it to the function generator so that I know I can get a nice solid waveform. So I'm just in the background here hooking up my function generator, and we'll see if this makes a difference. And I already disconnected these pieces of equipment since the last video, so I'm just turning them back on again. Okay, so I need to check my function generator output with the scope, so I'm just going to do that quickly. I want a square wave. Okay, so I still have my 0 to 5 volt setting with the right offset from before. I'm just going to knock the frequency down to about 1 hertz. And I'm going to use that instead of this clock input. It would help if I connected the right set of wires. I accidentally connected my scope to the circuit, which will obviously not work. The scope does not generate waveforms, it merely looks at waveforms. It is our function generator that is actually making the waveform. Okay, so now you can see the lights counting. 6. So, you know, indicating that there was nothing actually wrong with the circuit there, except my buttons, you know, when I press and depress them, I was getting little glitches, and those little high-low spikes were actually causing the counter to count. But now by taking my clock pulse from the function generator, I don't have those glitches, right? So looking at this circuit, I can see it counting, let's see, 12, 13, 14, 15, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 0 again. And you can see that I have that I have no glitches. So what I'm going to do now is I'm going to change the reset lines so that R1 is coming from QD and R2 from QB in your lab. So I'm going to have the most significant bit, pin 11. I'm going to connect pin 11 to pin 2. And I'm going to connect pin 9 to pin 3. So these, since these inputs are active high, I'm expecting that when we get a count of 10, this is actually going to reset. So let's find out. I am connecting, I'm changing my pin 3 to not be grounded anymore. It's going to go to pin 9, which is here. And pin 2 is not going to be grounded anymore. It's going to go to pin 11, which is right there. So let's see this count. 1, 2, 3, 4, 5. Sorry, I miscounted there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then it starts all over again. And that's exactly what we expected, because we set it so that it would reset, that the reset lines would get their high values when the output hit binary 10. And that was when the QD and QB lines were high. So that forced a reset, which was so fast that we couldn't see it with our eyes. But it forced that fast reset, and we went back to 0, which is why we only see 0 to 9. We don't actually see the 10 that drives the reset, because it is there for such a short period of time. Okay, so that's the last circuit there in lab 11. You just want to fill out the result on your lab paper and hand it in. Okay, thanks so much.